All right, good afternoon, everybody. I'm happy to be here and speak about energy harvesting in general and about organic photovoltaic in specific. As been said, Dracula Technologies is a company specialized in organic photovoltaic, or OPV. And we're here since 10 years, and we've been pushing the limits in terms of performance and design and shape. So I'll talk you through that in the next 15 minutes. And then afterwards, actually, there will be a panel discussion. There will be a couple of LoRaWAN device makers that are going to join me here in a panel discussion. So I look forward to the conversation. OK, so let's make a bold statement here. I mean, battery-powered IoT is neither viable nor sustainable, right? And it was said by my predecessors on stage. It's getting more clear to everybody here in the IoT community that large-scale deployments are just not viable because thousands or 10,000s or millions of sensors changing batteries is just not an option. It's just not, there's no business case for replacing batteries. Also, it's the continuity of the data coming from those sensors. It's typically the case that sensors run out of battery before somebody replaces them. And if there are critical processes relying on the data coming from the sensor, you can't afford the battery running out. The TCO is the issue where I've seen customers that did a proper analysis over a 10-year lifetime, 2 or 3 battery replacements. It just adds like 40% to the total initial cost of investment. So it's a major cost, which is usually very underestimated by enterprises if they deploy on large IoT solution. Sustainability, needless to say that if you have millions or even billions of devices and all batteries got to be changed, it's just adding to the waste that is not sustainable going forward. Then there's this lithium battery regulation issues with transporting that makes life also difficult if you ship thousands or millions of sensors, so it's not speaking for the battery option. And then the last one is de-risking. Supply chains are at stake here. There is trade wars going on as we speak, and at some point there might be an issue with delivering batteries. Our technology is based on mere organic materials, so we can always produce at any given time. So, having said that, I mean, autonomous devices or ambient IoT, as many people also refer to it, is the way to go for IoT. I mean, in the old days when we created IoT, we said, let's get away from cables and create wireless devices. I think the next transition is, let's get away from batteries and get into really fully autonomous devices. And once you get to a battery-free device, you have a maintenance-free device. And once you have a maintenance-free device, you can clearly say, connect and forget, right? We've been talking about connect and forget since 10 years. I think it's only possible with energy harvesting. Yeah, and it's been said before, there's different sources of energy harvesting, so I will not dwell too long on this, but of course light photovoltaic is a main source of energy harvesting. And within light harvesting, you have the silicon-based energy harvesting cells that we all know, from pocket calculators to photovoltaic cells on homes and stuff, all silicon-based and fairly cheap nowadays, but doesn't work very well in indoor environments. Then you have, of course, the organic PV cells that we'll talk about more later, which is the Dracula product. But you also have perovskite and DCC-based energy harvesting cells. Secondly, you have movement or kinetic energy cells that based on piezo or vibration. Thirdly, there's electromagnetic. We all know RFID, which is fully RF harvested. But also you have current-based harvesting on electrical cables that can actually yield energy to power up sensors. And last but not least, there's temperature-based harvesting. And actually a couple of manufacturers here, they have a temperature-based harvested device. Yeah, in terms of analysts, they predict that light-based harvesting will be the main source of energy going forward in 2028. More than 50% will be based on light harvesting. Second will be vibration harvesting, and then thermal and RF will be a minority. I have to say here, our RFID is not included in this pie chart because RFID does already billions and billions of tags, of course. So on light harvesting, as I said before, the crystalline cells, solar cells, work perfectly outdoor. We're not competing with that from a Dracula perspective. As the name says, Dracula loves to work in the dark. This is our strength. And we talk about dark like less than 1,000 lux. Here probably is like 300-400 lux. We can go down to 5 lux, right? So that's almost really dark. And in terms of robustness of a solution that works on light, there's variation of light that can be huge. I brought you 2 examples that we measured in an office space at the left. You can see close to the window you have more than 3,000 lux, whereas under the table, the desk is only 15 lux, okay? So if you design an IoT solution that has to run on light, you have to be very conscious of the light conditions and the variations, daylight, nighttime, sunlight, etc. Same in industrial environments, also high variation. So I think what I'm saying is if you want to really go for light harvesting, you want to be able to rely on a solution that even works with candlelight, right? So this is where Dracula comes in. In terms of our product, organic PV cells, it's a flexible film, right? Thin film. We can design it in any shape or form because it's inkjet printed. We don't have to produce masks to run a full production, a large series. We can actually do a very small series as a first iteration pilot, and the throughput time between your ID or your design and our production of whatever, 10 pieces or 1,000 pieces or more is a matter of a week or 2, right? So it's very short lead times in terms of iterating. It's cost effective, it's recyclable. We don't use any rare earth materials, it's all organic. And we have an industrial scale production in France, a large factory where we can really produce millions of films. Previously, I also have been talked about applications. From our perspective in Dracula, we have 3 main verticals that we see the adoption of energy harvesting. Smart building, CO2 sensors, thermostats, occupant sensors, all going to be built now with OPV, organic PV cells. Smart asset tracking, also a very exciting environment where we just, on this show, we're showing the smart label of Truvami that gives you location and condition monitoring. And there's a real big interest for this kind of products because it's just basically autonomous labels that can do much more than an RFID tag. Of course, an RFID tag is 10 cents, and a smart label will cost a little bit more, but it gives you full visibility and full transparency. And thirdly, it's the retail space and the consumer electronics space. We have customers in the ESL space, electronic shelf labels in stores, that also don't like batteries, of course, remote controls, obviously, and the wearables. Now, for the smart labels, I brought 3 customers that we currently have that deployed the Dracula OPV module. You see Linxens, that has a wire pass label developed. Then Truvami, as I mentioned, which is a LoRaWAN label. And we have Paragon ID, which is a Bluetooth-based smart label. All 3 are working with high pressure to get these labels to get to the market in full volumes, and actually have versions that can be run at a low cost. Now, why inkjet printing is best for organic PV cells? So first of all, it's the versatility of organic PV cells that are printed with inkjet printing, because we can do any shape or form and can do it at a very high precision. So for very small OPV cells, this is actually the way to go. Thirdly, it's the fast turnaround I mentioned before in terms of by the time you talk to us as a customer and we do a design together in terms of optimizing the electricity consumption in your sensor, by that time we can just print those labels in a matter of weeks, right? Or days. And it's very cost effective because we don't produce any waste from printing those labels, so it's not mask based, so we only print ink there where it's needed, so it's almost zero waste. Now, I want to announce here the Layer 2.0, which is the new product that we've been working on since last year when we were here. What we actually did is reduce the number of layers that we print on top of each other. So we just slashed 2 layers out of it and came down to 3 layers, which now is more efficient in terms of light yielding to energy. It's more stable as a product, it's less expensive, and we can produce it much faster, right? So this is a major step up for us from a production perspective, but also from a performance perspective. We have increased the performance of our cells on a per square centimeter basis by 40%. So you can see the graph here that shows the maximum power for a 6x6 cells, 6x6 centimeter cell at a warm light. With that, we come beyond the 1,000 microwatts at 1,000 lux. As to the graph, I apologize, the horizontal axis should not say Pmax, but should say lux levels. As I said before, lux level here might be, I don't know, 300-400 lux. So, but at 1,000 lux, you can expect 1 milliwatt, which is a 40% increase compared to our first generation of products. So yeah, we try to push the boundaries here. Our customers are, of course, requesting it from us. They want smaller sizes, more performance, lower cost. So we're investing a lot in R&D to get to this next level of organic PV cells. Also, we introduced a new option for customers to select texture. Instead of having only the glossy OPV cells, you can have a texture what fits your design. And like we have talked to building automation device makers that have hotel and other offices that want to have a nice look and feel. So we do textures. The shape is free to choose, completely 360. Whatever shape you choose, we can do it. And the number of cells. If you need more volts, you need more cells. If you need less volts, you can do maybe with 1 cell, right? So full flexibility here. Then, sorry, the color, I skipped it. This color can be blue or other colors instead of green. We only had green so far. We remember Ford also had only cars in black. We said we need to have more colors. It is a challenge in terms of chemistry, but we're getting there. So blue is available as well. Now what I show you here is the Layer Volt. It's a new product where we actually combine the harvesting on the front side and the storage on the back side, right? So you basically have a battery that is completely autonomous. So the product is getting into production by the end of the year, and we'll be shipping next year. And it's, as I said, it's a game changer. As far as we know, nobody has it. We got actually an award at the CES for this innovation. So quickly about the company, I'd like to say that we're a team of 40 people in France, in a city called Valence. So far, we invested 15 million euros in R&D. Have 29 patents pending or granted, and the production capacity is at 150 million square centimeters, having 1 shift right now working. Investors also, we have SEMTECH, we have MGI, a big one, ISRA, a big French bank, BPI, but also the EU funding. The EIC has invested significantly in Dracula. We're here since 10 years, so it's been a long journey to get to this level of performance and quality of products that we are today. So I spoke about manufacturing. This is a new plant that we opened up like half a year ago. It's fully operational. And I want to give you the sense of high tech. Because I mean, some people come to me and say, "Oh, you're printing those labels? That's like low tech." I said, no, that's is not trivial. So this is our factory. It's all clean room based, right? Because it's very, very sensitive to dust. Robotized production. Quality controls. Aging tests. So yeah, I hope you get the gist of it. It's really high tech that we built in that manufactory. Before I close, I'd like to point out that we're happy here that there's much more people from different wireless ecosystems than just LoRaWAN. Last time I was here, last year, I was saying like LoRaWAN, guys wake up, because other ecosystems are much more adopting the energy harvesting notion, right? I don't have to talk about RFID, of course, but talk about Enocean, talk about Zigbee, they all get to energy harvesting, battery-free. LoRa is a little bit lagging behind, so I challenge those in the room that still have LoRa sensors on batteries. You got to shift it from the batteries. If you really want to address large-scale deployments, it has to be battery-free. So for LoRaWAN, I'd like to sort of announce that we have a task force since June running, and 3 gentlemen of this task force that we have set up are here today, and we have a panel discussion right now, so please remain seated, and then we are looking forward to that conversation. Thank you very much.